Once again, welcome you all for this revision classes, which includes solving the some questions from your question bank only. Okay, so the start with this new chapter, that is balancing. In the previous video, we discussed regarding first unit and second unit, that is keys and coupling as well as shaft. Okay, in this video we're going to discuss some questions and problems regarding balancing. Okay, so start with first question, that is explain the balancing of rotating parts necessary for high speed engines. Okay, why the balancing is necessary for rotating parts, that is the question in high speed engines. Okay, nowadays we are using high speed engines, balancing is very much necessary. Okay, why that is rotating parts balancing is necessary, that is the question, simple. Okay, so answer is the high speed of the engines and other machines is a common phenomenon nowadays. Okay, it is therefore very essential that all the rotating and reciprocating parts should be completely balanced as far as possible. Okay, in day-to-day life we are using high speed engines. Okay, in that one so many parts we are having. For that reason high speed we are having, so for that reason balancing should be necessary. So for that one, so if these parts are not properly balanced, then what happens, dynamic forces are set up. Okay, so some parts we are not going to balance it, at that time dynamic forces may be set up. These forces not only increase the loads on the bearings and the stresses in the various members, but also produces the unpleasant and even dangerous vibrations. Because of this, balancing is necessary. Okay, so in this chapter we shall discuss the balancing of unbalanced forces caused by the rotating masses in order to minimize the pressure and on the bearings when an engine is running. Okay, so this is all about high speed engine, balancing is necessary. So this is 5 or 10 marks question may comes, so go through this question. Okay, similar, and this is very easy. Once you understand, once you read that clearly, you will going to write in your own words, no problem, nothing to worry. Okay, so second question, what are the important cases are considered in balancing of rotating masses? Okay, what are the important cases are to be considered during the balancing of the rotating masses? So following cases are important for subject point of view, means that why that important is necessary. Balancing of the single rotating mass by a single mass rotating in the same plane. Second, balancing of the single rotating mass by two masses rotating in different planes. Third, balancing of the different masses rotating in the same plane. And fourth, balancing of different masses rotating in the different planes. These are the some important cases are to be considered during balancing of the rotating masses. Okay, third question, explain clearly the term static balancing and dynamic balancing. Okay, so this question may ask for 5 marks. Okay, definition. So what is static as well as dynamic balancing? First, static, the net dynamic force acting on the shaft is equal to 0. This requires that the line of action, three centrifugal forces, must be in the same plane. In other words, the center of the masses of the system must lie on the axis of rotation. This is the condition of the static balancing. So this is all about static balancing condition. Next, dynamic means the net couple due to the dynamic forces acting on the shaft is equal to 0. In other words, the algebraic sum of the moment about any point in the plane must be 0. So this is all about the condition regarding dynamic balancing. The condition 1 and 2 together give the dynamic balancing. So both are the gives the dynamic balancing. So this is all about 5 marks question. And this one is important. Discuss how a single revolving mass is balanced by a single mass revolving in the same plane. So you have to draw the diagram, this one, okay. So this is important. You have to draw this diagram and write the equations like Fc1 centrifugal force 1 and 2, okay, which indicates the final this equation. So start with some explanation regarding this single revolving mass balanced by the single mass revolving in the same plane. So considering a disturbing mass m1, okay, m1 is to be considered as a disturbing mass attached to the shaft. So here the shaft is fixed to that one, this m1 is fixed, so that is considered as disturbance mass. It is shown in the figure. Let r1 be the radius of the rotation of the mass m1. So that is distance between the axis of the rotation of the shaft and the center of the gravity of the mass m1, okay. So hence for that from the previous subject and previous chapter, we know that centrifugal force exerted by the mass m1 on the shaft, that is Fc1 is equal to this m1 omega square and r1. This centrifugal force acts radially outwards and thus produces bending moment. So it produces the bending moment on the shaft. So because of continuous work exerted on the shaft, so henceforth it will indicates bending moment. In order to counteract the effect of this force, balancing mass m2 may be attached. So in order to avoid this disturbance mass, m2 is to be fixed here and here, okay. So that is, in other words, let r2 radius of rotation of the balancing mass m2, that is shown, and centrifugal force due to the mass m2, and fc2, hence fc2 is equal to, once again, sorry, so here fc2 is equal to m2 omega square into r2. So just same as this centrifugal force equation 1. So equating these two equations, so finally we're going to have this equation, okay, that is m1 into r1 is equal to m2 into r2. So this is all about this single revolving mass is balanced by this single mass revolving in the same plane, okay. So this is 10 marks question. It is important. You just go through the previous question paper, you're going to understand, okay. Then moving on to the next question, that is explain the method of balancing of different masses revolving in the same plane, okay. You have to draw this diagram for explanation regarding this one, okay. So this first one is space diagram and second one is vector diagram, okay. Both are necessary while explaining. So considering any number of masses, means that whether it may be 4 or 5 masses, magnitude of m1, m2, m3 and m4, okay, we considered as 4 masses here, and at the distance which is connected, which is fixed at the distance of r1, r2, r3 and r4 from the axis of rotating shaft, okay. Here it is clearly shown like that, okay. Let 1, 2, 3, 4 and be the angles of these masses with the horizontal lines ox1, okay, it is shown in the clearly in the figure. Let these masses rotating about an axis through the O perpendicular to the plane of paper with a constant, okay. So it is not clearly shown in this figure, but this indicates that this is the complete explanation regarding balancing of different masses revolving in the same plane. So we have to consider this space diagram as well as this vector diagram. Okay, so balancing of several masses rotating in the same plane, explanation this one. So this may ask for 10 marks. Okay, you have to go through this as well as notes it is given clearly. Next, so this is regarding theory questions. Okay, so 1 2 3 and 4 questions, 5 questions regarding theory questions. So in that 5 questions, they may ask 1 or 2 questions for 5 or 10 marks. Okay, so next, moving on to the next part, that is problems. First problem: 4 masses m1, m2, m3 and m4 are 200 kg, 300 kg, 240 kg and 260 kg respectively. The corresponding radii of rotations are 0.2 meter, 0.15 meter, 0.25 meter and 0.3 meter respectively, and the angles between successive masses are 45 degree, 75 degree and 135 degree. So these are the given datas. Okay, what he told to find the position and magnitude of the balanced mass required. Okay, so he told to find that position and magnitude of the balanced mass required. Okay, so first write down the given datas. So here given datas are m1, m2, m3, m4 are the given, as well as at the distance radius is given, r1, r2, r3, r4. Okay, at the angles also given, means that on that angle particularly that mass is to be fixed. Okay, at the given distance. So here theta 1 0, theta 2 45 degree, theta 3 is equal to 45. Means that one thing you have to remember, that so whenever he in the problem itself, so he may ask like successive masses. Okay, so if he used the word successive masses, then you have to add the previous degrees. Means that once you taken the 0 degree, means that it is 0. First one is theta 1 is 0, second theta 2 is 45 degree, but in third degree successive masses if he given, means that you have to add the previous degree. Okay, that will give the theta 3 as well as theta 4, like that. So it is added in this problem. Okay, so just see here theta 3 as well as theta 4. Okay, theta 3 and theta 4. So added 45 degree plus 75 is equal to 120 degree, and theta 4 is equal to that 120 plus 75. Okay, so that is 255 degree. And next, radius given. Okay, 0.2. So here these are the given datas. Then start with the solution. Means that m, so here m is balanced mass and theta is the angle. So just now only I told. And since the magnitude of the centrifugal forces are proportional to the product of each mass, so therefore you have to add like this: m1 into r1, add the values, and you are going to get the magnitude of the centrifugal force. Okay, m1 r2 and m2 r2, m3 r3, m4 r4. Okay, like that you have to do the that magnitude of the centrifugal forces. Then the problems may now solved. It may be solved for analytical as well as graphical. Okay, so we will start with analytical. So here, while solving analytical method, the space diagram is to be drawn. Okay, space diagram is to be drawn for analytical as well as graphical methods. Both are necessary. If you drawn this space diagram, once you drawn this space diagram, definitely you are going to get 2 marks. Okay, 2 or 1 marks definitely you are going to get for this space diagram, not to worry. Okay, then solving with the analytical method. So here revolving m1 m1 r1 m2 r2 m3 r3 and m4 r4 horizontally. So you have to use this formula. Sum of h means that sum of horizontal that revolving spaces means that m1 r1 like that you have to take with the help of this formula. So add all the values in this sum of h formula. Okay, then you're going to get sum of h value is 21.6 kg meter, and similar to the sum of v vertically resolving. Okay, that's why sum of v you have to take, and instead of cos theta 1 just you have to use sin theta 1. Okay, so this is the formula for sum of v. So substitute all the values, and finally you are going to get 8.5 kg meter. Then next, resultant we need to find. So r is equal to this formula you have to use square root of sum of h square plus sum of v square, and that will gives the 23.2 kg meter. Then m into r you have to do, then it will gives the that m value, and you have to use tan theta inverse. That formula is sum of v divided by sum of h. 8.5 divided by 21.6 is equal to 0.3935, and you have to use in terms of that theta. If that unknown degree is not given, then we need to find that unknown degree with the help of this formula. Theta is equal to 21.48. Since theta is the angle of the resultant from horizontal mass of 200 kg, therefore the angle of the balancing mass from the horizontal mass of 200 kgs. So that's why you have to add 180 plus 21.48, that is 201.48. that is the final answer. Then solving with graphical method. The magnitude and the position of the balancing mass may also found graphical, discussed below. Okay, so first step, first draw the space diagram and shows the position of all the given masses as shown in figure. So here that is shown in the figure clearly. This one is that figure. Okay, space diagram, and you have to draw the space diagram with the help of that one only. Draw the vector diagram, but instead of that, centrifugal force of each proportional to the product of the mass and the radius you have to calculate. This one m1 r1, m2 r2, m3 r3, m4 r4 values. Okay, so with the help of this one only you have to select the scale and draw this vector diagram. Okay, so it is somewhat some problem we are getting in this class, because it is not accurately possible to tell you that how to draw this diagram. Okay, so but in class I told very clearly how to draw, means that you have to take the some scales. Okay, so during that one only you are going to understand and draw that clearly the vector diagram. After drawing, you have to measure this distance and convert into the scale. Okay, so here it is clearly converted, and finally the answer is like that 115 kg unknown mass is to be will going to found, and that unknown angle is 201. Okay, just now only we found in while solving with analytical method. Okay, by comparing with that you will going to understand that problem is correct. Okay, so you just refer the notes. Okay, so I clearly shown how to draw as well as how to solve with the help of that analytical method. Okay, so next problem, that is homework for you all. You have to practice in your home. 4 masses m1, m2, m3 and m4 are 250 kg, 350 kg and 290 kg and 310 kg. respectively. The corresponding radii of rotation are 0.25, 0.20, 0.35 and 0.4 meter respectively, and the angles between successive masses, okay, successive masses is given 75 as well as 135. Find the position and magnitude of the balancing mass required if its radius of rotation is 0.25 meter. Okay, you have to solve graphically. Okay, it is I think not solved, unsolved problem you have to solve. It is very easy, similar to the previous one. Okay, just go through that notes, then you will going to understand. Okay, so this is all about balancing mass revision class. Okay, and important questions selected from your question bank only, okay, which may comes for your forthcoming exams. So that's why we are telling that you have to refer this video for your study purpose, okay, which almost covers your revision portion, and this problem will helps to understand the analytical as well as graphical method. This is homework problem you have to solve. If possible, after solving you have to send in the WhatsApp group. Okay, so this is all about the revision class. If you have any doubts, you call and clarify. Okay, but don't stop to study, okay, because exams may announce at any time. So all the best. Okay, do well. Thank you.